Welcome to the text analytics workshop. There's a much longer title I wrote for this, something like "Don't Fear the Text." I wrote that and submitted it when I was still in the throes of wrapping up some stuff for my PhD, so it sounds super important and extra grandiose. And then I looked at the names of the talks that were here, and I was like, I lost the plot. Okay, but you could just call it the text analytics workshop. So a quick overview. I'm just going to do an intro into the problem or the quandary of working with short-form, open-ended text and the varying ways it shows up. Some common methods that I've used in the past to explore some of this data and kind of scratch the surface as what's going on with some of this data. Just to double check, you all can hear me okay? All right, awesome. I'll go onto my little soapbox for a little bit on the strengths and limitations of some of these methods. And I'm really hoping that's not going to take too long, because after that, we're just going to jump right into a guided workflow. So we've got some example data that I was able to pull from open data. And we're kind of just going to go through it bit by bit. We'll do a bit of exploratory descriptive analysis of some of the text data that we have. We'll do some sentiment analysis, which will boil down in some statistical modeling. And then I hope we'll have enough time to wrap up with some word correlations and node maps, which will kind of allow us to kind of get at some themes in our text data after we've done some exploring and done some modeling. All right, so that sound good, everybody? Awesome. So a little bit about me. Hi, I'm Devin. Currently I work as a data science educator at Posit, formerly RStudio. Recently, back in August, I wrapped up a PhD in experimental psychology. And then I also have some experience working in analytics and kind of in the market research sector and then the higher ed program evaluation space. I say all of that to say is that in one form or another in all of these levels of my education or kind of career background, I've worked with in some form open-ended short form text data and have slowly started to perfect my craft and just working with some of that data. And so the goal of this workshop is really for me to showcase to you all here's an example workflow and what you can do with some of this text data. So like I mentioned, this short form text data, it shows up in so many places. If you're in academia, you might be working with experiments where you might have your participants write an essay or a short form prompt. If you're in market research, you might have people leave a short review for a product. If you're in program evaluation, you might have students or people who are in your program, write something brief, recommendations. From my experience, more often than not, a lot of that text data kind of gets put to the side. And the main reason is that we don't have enough bandwidth and capacity to do a meticulous, in-depth qualitative analysis to see what are some themes that are coming up in that data. It's usually we can get to it, especially from my own background in kind of psychological research. We have so many different kind of experiments where we'll ask participants to write about things in the past or certain psychological process we're interested in. The goal is just to induce them into that state, but we don't actually look at some of that actual text data, but that's a pretty big missed opportunity, I think. And that's one of the many reasons why I started to kind of explore how I could start to analyze and think through some of this text data. So yeah, kind of what I already said right here. I think the big thing is that at the end of the day, we're missing so much useful information. People who do answer in short form text responses on surveys or in experiments, they are telling us their experience within the context of something we've asked them. And when we don't use that data, we're wasting their time and wasting our time, because why do we ask it? So the framework that we'll be working with today during a workshop, I'm pulling a lot of this. I'm primarily going to be using the Tidytext package put together by Filji and Robinson. And in the resources for this slide deck, there will be a link to the book itself, which is open and free, and you can kind of go chapter by chapter at different methods and different approaches you want to analyze text data with. But I'll be borrowing quite heavily from them, especially when we go through the actual notebook itself, when we look at some of the standard processes of structuring your text data and then starting to do some analyses. So some examples, some things we'll look at. As I mentioned before, we'll hopefully at the end get to some stuff where we could do these kind of node maps, where here at the top we've calculated how the extent to which varying words are correlated within broader text corpuses. And then we plot that and we go, okay, what are the clusters of words which might give us an indication as to what type of themes or ideas or things that are being said in the text corpus. We can also do things like sentiment analysis. We can look at the overall polarity of text when we've mapped them onto sentiment lexicons, which rate words in terms of polarity or categorize them in certain emotional contexts. So those are some of the examples. I don't have it per se immediately right now, but I have resources at the end where you could do some topic modeling, and I'll get into what that means and what that's all about at the end, especially if there's time. It's mainly just how you'd restructure your data and what that method is trying to do. So as I mentioned, I've been exposed or been working with open-ended text data in some form or fashion throughout most of my professional career. So some examples of how I've leveraged these methods in the past. So like I said, my background is in experimental psychology. This is a plot from a paper I'm trying to get published right now, but it's very common for psychologists to ask participants to write about times in which they felt that they were in positions of power, or write about times in which they weren't in positions of power and people had control over them. And we do these experimental contexts to induce these emotional states. And then we don't look at the damn data. Sorry, excuse me if I was curious. We don't look at the data, but I had used some methods like this and could basically look at kind of differences in emotional polarity across conditions. So I could identify that, oh, this method actually seems to be working at the very least when I analyze the types of things that people talk about. I can actually see differences in overall emotional valence. I have colleagues in kind of the medical education research space who look through a lot of comments on how residents and faculty feel about overall assessment of students when they're going throughout their medical education. More often than not, well, sometimes we won't have enough time to look through some of that open-ended text data, and so we've applied some of these methods to kind of analyze where there might be trends. And I've also, using methods like this, I've been able to train students to think not only quantitatively, but also qualitatively about language data more broadly. I've had students come to me who are interested in doing qualitative analysis, but they have very basic questions around some descriptors that we could pull out of that language data. And so frameworks like this have been really useful to get those interested in working with language data in general, how to just flexibly think about working with that data more broadly. So that's my elevator pitch as to why this is all important, or why I think you all might benefit from this. So some friendly reminders before we get to the notebook, because that's pretty much where we're going next. Some friendly reminders and caveats is, especially when we get into some of the methods used, where we're analyzing average emotional valence, which is going to be rating individual words. Like, there's a lot of context that we lose from some of that. It leads us to some interesting trends, but we are losing some of that context. And so this is a friendly reminder that at the end of the day, a lot of these methods, even the more advanced ones, we are just scratching the surface of that text data. In no way, shape, or form, I would argue, are these methods a replacement or an excuse not to do, where you can, good qualitative work. If anything, I think you could probably use them in conjunction, where a quantitative analysis of some language data might inform, or you might guide a subsequent qualitative analysis, especially when there's large text data at scale and you don't even know where to start, don't even know where to go, or whatever a priori thematic or theoretical framework you want to do a qualitative analysis with. And finally, to own the subjective component, or what I would call the researcher degrees of freedom with some of these methods. Especially when we engage with things like sentiment analysis, where we'll be working for this demo like with pre-established, pre-validated sentiment lexicons. There is still some contextual realities around certain data. For example, certain sentiment lexicon may be really useful for just like review comments for a particular product, but they might not be good for psychological data or for program evaluation data. And there's a subjective component in there in which I would encourage, as it's been encouraged by people who trained me in some of these methods, to design some of your own lexicons. Design and focus on some of the words or the phrases that you're interested in when you start to analyze your text data. So owning up front that there's gonna be that subjective or those researcher degrees of freedom when you get into analyzing data like this. So We are going to use the NICAM emergency notifications data as an example. We'll be going through some categories of different emergency categories. We'll even be exploring a little bit of temporal analysis, see if there are changes in emotional valence over time. And we'll just be exploring this data. As I mentioned, well, one, you could pull this data itself. But there's also a GitHub repo where you all have access to at the end of this, where you can take a look at the code and some of the data in and of itself. So I'm going to stop the share, and I'm going to reshare our Markdown, my quarter document. Okay, perfect. All right, so we are going to be in the data in and of itself. I've loaded most of this, so it should be fine, but this is what the data looks like. We've got record ID, we've got date and time, we've got the notification type, we've got the notification title, which is mostly blank, we've got the email body, this is what we're going to be working with for the most part. You'll notice if you look at the start of here, most of these start off with this is a message from Notify NYC or notification 2 issued. By default, a lot of this isn't going to be really useful. Now, I would love to say that I have some really fancy, short, and good-looking R code that just like focused on these strings and remove them. In reality, I just pipe this into Excel and I just removed all the excess data that I know, the language data that I know really wasn't going to matter. So in the data set that's on the repo and that you can access, I've kind of cleaned this out where I've removed some of those extra things at the start, and that's what we'll be doing most of our analysis with. So big picture level, this is what the data looks like, and we're going to get started. So we can take a look at this. We can take a look just over at the head of the data. One of the first things we're going to do, and this is where we'll be bringing in the tidy text package almost immediately, is we're going to be using this function, this really nifty function called unnest tokens. And what unnest tokens is going to do is it's going to restructure our data into a format that's going to allow us to work with the individual words in all of our text corpus. So if we look at the structure of our data, right now it's in this wide format where each observation is each individual notification. We want to restructure that data. We want to structure it in such a way where each row is a unique word tied to each record ID. So that's what the unnest tokens are going to do. So the reason why there was a start at there is I really wanted to like live stream this and kind of do some live coding so y'all could see this. Basically what we're going to do is we're going to run this chunk where I'm just going to select my variables of interest, and then I'm going to use the unnest tokens function. So I'm going to unnest tokens, I'm going to say word. Word is an arbitrary thing I'm just creating, but I'm saying, hey, pay attention to my data where there's actual text. And when I run that, we've restructured our data in this way where now each row is a distinct particular word from each of our individual records. You'll notice kind of at the start, there are some words like as or per or the, which we could probably make an argument aren't going to matter too much in terms of the content as to what the overall message is about. So one of the things we can do is we can remove those words with an anti-join. By default, in the tidy text package, there is a data set called stop words. And as we're working through a lot of these sentiment lexicons or other data sets, what we'll notice is that they take the form of a data set that just has word and lexicon. And that's going to be really useful for us because using unnest tokens, we just reshaped our data where we have a column called word. So now that allows us to be able to join our data onto varying different sentiment lexicons so we can do some subsequent analyses. So for right now, I'm going to remove words that I think aren't really going to matter that much. I'm going to anti-join that onto stop words. Bringing this back into the subjective component of the analysis, there might be words in this stop words dictionary that are actually important to your particular text data. So a key component when you're starting to work with your own text data is to get familiar with what that text data is, the context of it, and then make decisions as to when you're going to remove certain words. There might be certain words that matter. The example I can bring, I trained a student on these methods, and he was really interested in the frequency of first-person pronouns that were in certain responses that people wrote. That might be removed in this stop words dictionary, but we didn't remove them in that data because that was a core bit of language, a bit of data that was interesting or important for them. So we'll go ahead and just run this. We've got our tidy data frame, or tidy words data frame. It's going to look like this. So now we've restructured our data, we've anti-joined onto our stop words. We'll notice that we have a lot less words than initially. So by default, there are a lot of words that are just deemed not as important. So now we just have core content-focused words that we think are meaningful to each of these individual records, and they've been stored in our data set. So now we've got this data reshaped in this format, and before we do anything really sophisticated, we could just start to explore and just do some basic descriptives. So what are some words that are going to show up more frequently in this data set overall? So we can take the top 20 words, and so I'm here, I'm just saying, hey, count the words and give me a sort by the ones that show up most frequent. So I can look at, okay, expect delays, due, alternate street, routes, time, travel. I can start to get a feel, okay, what kind of words are showing up in my corpus. As we noticed when we looked at the notification type, we have different types of emergent fee that are categorized under different contexts. So I explored that a little bit, and I said, okay, what if I wanted to filter for what are the most common words that show up in the planned events notifications? So I can filter my data for that and do the exact same thing. And now I can see, okay, PM approximately 00. Some of these words I actually might want to remove myself. They might be quite meaningless, but some of them I'll actually have to filter and look and see, well, where does 30, where does 6, where does 00, most likely indicative of like midnight or something, where is that coming up? But I can slowly start to do some descriptive analysis in terms of what are the words that are showing up in my data. I'm not limited by just making tables. I can graph all of this. So I can, in this instance, I'm doing some more filtering. I'm just going to say, show me common words in emergency activity and public health. Do the exact same format where I want to count these words. But now I want you to turn that into a graph, and I want you to make it in a nice ordered graph where I can take a look at some of the most common words in order across these two. And I can visualize this and think about what are the words that are showing up. I have this in graphical form. I can also incorporate, I can also split my graphs by different conditions. So I can go, all right, emergency activity, public health, local mass transit. Show me the top 10 words in each of those, but let me take a look at those graphs side by side. So I can, it's not as clean as I'd like it to be, but we can take a look and we can look by all of these three conditions. What are the words that are coming up most frequently, and to what extent are they coming up by those conditions? So we can just start to do some general exploration. We've got these words that are now isolated, and we can go, what are the words themselves that are coming up in our broader corpus? A question?
By the way, what is the website for your GitHub repo to access?
Oh, yeah. I posted it in the message. What I might do for right now is I'll post it at the end, because that would require, I'd have to unshare it. It's on like my GitHub, and yeah. So, but I can definitely post that up and put that in the slide deck at the end. So we're doing some descriptors. We're just looking at the core words, but now we can start to move into some sentiment analysis, starting to look at emotional valence. And one of the things we can do is, within something like the TidyText package, we have kind of pre-established sentiment lexicons that we already have access to. You can download additional sentiment lexicons. My research, broadly speaking, is in like the psychology of dehumanization. So there are like experts in psycholinguistics who have put together sentiment lexicons that capture certain words that are pretty important and salient for that particular phenomena. So in some research I've done in the past, like I've grabbed those from online and put them into my R project and joined them onto my data. And that's what we're going to do in this instance with the sentiment lexicons that are available to us. So mainly we're going to work with these two, NRC and AFIN. What's really useful about these, so NRC in particular, what it's doing is it's categorizing words by particular sentiment. And so there's roughly about 9 or 10 emotions overall, so like anger, trust, fear, disgust. So we can do some interesting categorical analysis, or what we'll do later on, like some frequency analysis. But we also have dictionaries like AFIN, which give us quantitative ratings of words. So in AFIN's example, it's going to rate words anywhere from -5 to this is the most negative we could possibly measure it or think of, conceptualize it, and +5. So this is like a really positive word. So we can do some quantitative analysis given that we have a quantitative measure of polarity with certain words. So we'll play around with 2 of these sentiment dictionaries. Bing is also really useful, but it primarily categorizes words as just positive or negative. So, structure of the data, or the structure of the sentiment lexicons. Yep.
So with things like sentiment dictionaries, like how do you adjust them if, like maybe you disagree with the characterization, maybe like for particular context you just get in certain words, maybe don't have that same level of activity. What do you do then?
Yeah, that's a really good question. So the question is, what do you do if you disagree with kind of the categorization or the rating of a certain word? Given, especially with a lot of these, that you can just access them. So these, for example, you can access them as data frames. What you can do, you could edit that data frame if you choose within the context of research, just being very transparent in terms of how you've edited them. When I started working on some of sentiment analysis for some of the data tied to me, I was very much encouraged by one of my mentors to create my own. So I knew what words were going to be of interest, and I knew how certain researchers had kind of coded them in the past. But with the data that's available, especially in a package like this is the data frame. We're accessing a data frame, so when I call NRC, I'm going to get this data frame. You're seeing a condensed version of it because I'm just showing like the top 6 rows, but you'll be able to just manually edit that. So if you disagree with how a lexicon has rated certain words, go in there and explore, maybe tweak it, and then just specify that this is the edited version suitable for your data.
How do you view like all the large language models fit into this kind of framework from like a sentiment perspective? Do you view it as maybe like another option, or do you prefer something like this where you can be really customized and nuanced into your field, or what do you kind of think about?
Yeah, so that's so the question is kind of where, and let me know if I'm summarizing right, but the question is kind of where does this fall in the broader category of your large language models in particular. This is not in that super deep, advanced like LLM. We're not doing anything GPT related. At the end, we'll touch on something like topic modeling, which will actually start to look for deeper themes or topics in language data, and that's going in that direction. But I'd say probably the best use and the way I've used this data is for more of that short form text. For those large language models, I mean, you need much more language data. So like if you're working with like maybe a survey of like maybe like a couple, like maybe like 1,000 or so like short form reviews, might not be the best. But then I would argue like methods like these would be really easy to kind of just throw in your data and start to work with the text data in and of itself. All right, so let's take a run through. Let's do a sentiment analysis using the NRC sentiment lexicon. So I'm going to take my tidy words data frame and I'm going to do an inner join on the NRC data set. I'm going to join it by word. We have that useful column that we created, and what we're going to see is kind of the caveats or limitations. We're noticing we're losing like the frequency or the amount of words that are available in the data. We've done that inner join. So speaking to an earlier question around the limits of sentiment lexicons, some of them might even be capturing all of the words of interest, and so that also might be a component of where you might want to edit or add if you know that there are some words that you know are important, and then how you might want to categorize them or think about them. So when we inner join, we now have on our data frame, we've got this additional column sentiment, so we know how the dictionary has rated certain words by varying emotional categories. And now we can start to do some analyses around what's the emotional valence of our overall text corpus. So I can go, as opposed to counting the word, I can go, well, count the emotion, and then give me a proportion. What's the proportion of positive words in my entire data set? What's the proportion of anticipation, et cetera, et cetera. I can graph that as well. So tables are useful as we're doing some exploration, but I can also graph them. So now I can take a look at overall kind of what's the emotional valence spread in my broader text corpus. But I can also, going back and focusing on this notion of categories in our data, so we know with the emergency data set we have these categories by notification type. Let's say I just wanted to pick 2 by random, so local, mass transit, and transportation in general. So I can make the same type of graph. In the notebook, I have this like in the published notebook that you'll see on the GitHub repo. They're kind of, the 2 graphs are side by side. But for here, we'll kind of look at one at the other. But when we look at the emotional breakdown or the valence breakdown by local mass transit, we'll see like more often not positive words, unigrams. Unigram is higher frequency of positive words. When we look at transportation, we see the top one is anticipation. So a question I might have, like I can visually see that there's a difference in positive word and the frequency of positive words or the frequency of words tied to anticipation. So that might inform a research question I might have. Maybe I could see if that difference across those different emotional contexts are statistically significant, and I could even maybe dive into by what extent or what's the kind of overall effect side of that model. So what this code is doing in this instance is I'm just grouping by record ID, and I'm counting by individual record how many emotion type words are in each record. And I'm reshaping my data and joining it back onto itself, where now this is what my data set looks like. So I have record ID, the count of anticipation words, the count of fear words, negative words, et cetera, et cetera. Now this is looking like something where I could probably do some modeling. I've taken my language data and I've extracted something quantitatively useful from it. So in this instance, I'm working with count data. So we're looking at how often are like anticipation words showing up across all of these records. So what I can do, if I can put together a Poisson regression model. So in this example, what I'm doing is I'm filtering by local mass transit and transportation in my data set. I'm factoring it so I can interpret my regression a little bit easier. And I'm piping all of that into a statistical model where I'm saying, model the frequency or the count of anticipation words as a factor of notification type, which we filtered by these two levels of interest, and letting you know at the end, hey, this is a Poisson model, so we're only dealing with increased number of counts. So we can take a look at our model, and
What's the thinking of the Poisson model?
huh?
What's the
Sorry, this went all the way down.
process behind choosing that?
So we're choosing a Poisson model mainly because we've counted the frequency of words. So if you think in terms of like, if you're doing like a standard linear regression, when we're looking at like how we assess like model residuals, that's incorporating the idea that there are negative values and positive values at an infinite level. But since we have count data, like there are no negative counts. So in terms of like assessing the robustness and like, are we using the best model to fit that type of data, your Poisson distribution is acknowledging that there are counts and not negative values. So that's why we do that. So we can take a summary of our model. I don't know why this keeps spurring or heading all the way down to the end. Okay, sorry guys. This is taking, or it's sending me down to the end for some reason. What I might do is, I'm gonna try this one more time and then I'm gonna switch to the knitted version of the notebook if it doesn't work. It didn't work, okay. So here's what I'm gonna do. Okay, we've got the PDF, okay.
If you wouldn't mind, can you minus the
Huh?
thing on the right or which side?
Minus the thing on the right.
You see this little bar there? Can you just press that? I think that button will do it. Yeah, there you go.
Okay, perfect. All right. I want to do the whole live coding thing, but just in case we're like, let's actually save this into a notebook. So we can take a look at the summary of our model, and we could say that, okay, relative to local mass transit, transportation has a higher count overall in words associated with or are categorized as anticipation. And we can tell that that's statistically significant. If you're a bit of a stats fanatic like me, I'm not as invested or excited about statistical significance. I really care about the effect sizes. So I can just pull out the model coefficient here, and since we're doing a Poisson regression model, we can exponentiate that, and we can see that interpretation-wise there's effectively roughly about 47% higher count of anticipation-related words in that data set across those two conditions. So we can have a research question about what's going on in our data, and then we can answer that once we've reshaped our data and pulled some relevant quantitative information out of it. So, and then what this chunk of code is actually doing, well, since I know that there's some statistically significant difference with a pretty moderate, pretty large effect size, I actually go, well, in my data set itself, what are those anticipation words that are in both of those categories where there's a difference among them, and I can filter for across those two conditions and go, yeah, show me the most frequent words associated with anticipation. So that would be expect, time, closure, approaching, rail, tomorrow. I could do a further deep dive and just looking at all of those words in general and going and thinking more about the impact of my overall quantitative analysis of this text data. But we're not just limited to these types of approaches. Like I mentioned before, we can use that AFIN sentiment lexicon where words are kind of categorized in terms of like polarity from negative to positive, where we have quantitative ratings for that. So what this chunk of code is doing is similar to what we did with the NRC data set. I'm mapping the AFIN dictionary onto my initial cleaned up processed words. I'm grouping record ID, and in this instance I'm taking the average valence across like all of the words within each record. And so that gives me a data set that looks like this, where now by record ID, as opposed to the counts of individual emotion-based words, I now have what's the average polarity of the emergency notification for record ID 1, 2, 4. As you'll notice, and as we saw something similar when we joined our data onto the NRC data set, we're losing a lot of information. We're losing some proportion of our text data. That's because our sentiment lexicon isn't capturing all of the language, all of the words in our raw data. So that brings into a different conversation or more caveats around the limitations of some of these approaches. But just as before, now we can do a simple model. We can go, yeah, is there a difference? Is there a difference in average valence by notification type? We can run that as a standard linear regression model. And we can see, yep, relative to local mass transit, transportation is actually more negative in this instance, because now the sentiment dictionary is giving us a different measure overall. So we can see that when we actually take a look at our model output. We can do this in the t-test example, and then one thing I like to do really a lot is when I run a model, since I don't always, the reporting part is not my favorite, I'll just pipe this into the report function from the report package and go write the results for me, so I can just copy and paste and we have everything we need. So that's great. Let me see here. What I want to move into next, so we've done kind of two examples of like a sentiment analysis where we've looked at differences in frequency by certain emotion words or differences in overall polarity, but we've just been focused on notification type. But we have so much other data in this emergency data set in particular, and one of the things we have is we have the date and time that each emergency notification was sent. So is there something we can glean about overall emotional valence throughout maybe the time of day? Is there differences in valence across like the time of day? So kind of walking through it bit by bit, what this code is doing is I'm filtering by my categories of interest, but what I'm doing is I'm extracting the hour of the day from the date and time variable, and then grouping by notification type and hour. For the hour of the day, I'm now getting average valence. So I'm getting the average valence of local mass transit at midnight, or transportation at midnight, and et cetera, for this kind of larger data frame. And that's kind of what that looks like right here. I can then just analyze, I can do just like an exploratory kind of trend analysis. Are there differences in emotional valence across these two conditions over time, throughout the time of the day? Ignore that, sorry. And then I can take a look at a plot like this, where I can say, okay, I can also see the differences in polarity across these two conditions, but I can also make some guesses as to, okay, it seems like at 1 o'clock, the emergency notifications for transportation are the most negative. Slightly similar for local mass transit, which is roughly about at maybe like 2 o'clock. And so I can do some types of trends over what's emotional valence look like over time. I can do that with this data set, or these are just things in general I could do with text data if I have all of these other types of data with me. And this was just like a more like, if I wanted to make it more scientific and throw my error bars in here and look at just like overall emotional valence over time and acknowledge like general error. So, so we've covered sentiment analysis, how we can look at differences across categories, differences in emotional valence across categories, explore and look at emotional valence over time between conditions, some things we can do in relation to that. But where I want to kind of wrap up and kind of leave you with is this aspect of looking at clusters of words and one of the ways in which we can do that. So one of the ways we can, using some additional packages, including packages like the YDR or iGraph, is what we're going to do is we're going to calculate what's referred to as the phi coefficient, separate or different from a Pearson correlation coefficient, which is really good for numerical data. A phi coefficient is really good for looking at correlations between words or categories in particular. So what I'm doing right here, and just for this example, I'm looking at like transportation for an example, and I'm filtering for words that show up at least 200 times in my text corpus. So we have a pretty large data set, of a ton of words. So for right now, and this is kind of arbitrary, and you can customize that, but yeah, at least words that show up roughly about 200 times, filter for that. And now I want you to actually compute a correlation coefficient for the words as they show up within the records. In this instance, I'm actually filtering my correlation, my phi correlation coefficient by roughly a medium effect size, so anything between 0.3 and 0.4. But what that looks, and you can remove that if you want, but what that looks like is something like this, where I know like, okay, additional traffic, traffic routes, time in traffic, these are words that are correlated in my text corpus, especially when I filtered my data for something like transportation. And what I can do with that is in this semi-annoying but long bit of code, if I'm taking that word correlation data set and I'm piping that into a broader graph that's going to actually allow me to actually look at the clusters of words. So that will look like something like this, where now I can process all of my text data and I can start to look at where are words clustered. So in Gowanus and Brooklyn, or Upper Bridgebound, Level, East Street, or Manhattan East Street, I can start to get a rough idea as to where are certain words correlated in my data, and that might inform or influence where I might lead a subsequent qualitative analysis, or where I might train a topic model in particular. If these maybe come off to appear like maybe 1, 2, 3, 4, maybe 5 or so clusters, there might be 5 topics or themes that might exist in my text data in particular. So, oh, actually, we're way ahead of time, which is really good. So the last thing I kind of want to leave you with in this demo, and then I can take questions and answers, and then also, if there's time and if people have access, I can just reshare my notebook and we can do some live stuff, and kind of just do some live question and answer, kind of like working with data set. We looked at just under analyzing individual words per se. One thing that we can do as well, and this is kind of outside of the framework, is we can also try to identify certain texts that follow certain patterns. And so I'll leave you with like a little bit of code that's like an example of that. I was thinking of something, wasn't very creative, but we know at the start of the data set there was that earlier column that had all the extra, like this is a notification from New York City. So what I could actually do is in this bit of code, I'm basically doing a case statement where I'm saying, does my record say the thing that I'm interested in? And so I can create a case statement where I go, here's a pattern of text I'm interested in, look for it in this data frame. Does it have it? Then give it a yup. Does it not? Then no, it doesn't. And then I can actually see how I could start to identify within my text corpus and categorize that in my actual data. Here's a particular pattern of text I'm interested in, flag that in my data, put that in my data frame, and that might inform more of how I do an overall text analysis in general. So that is kind of the demo, and mainly how I kind of have it set up. I didn't get into something like topic modeling, and the main reason I didn't do that is because we'd restructure the data in an entirely different format. I don't have a marker. OK. Thank you. I'll kind of leave off with this before we get into the Q&A bit. But so we've structured, been working with our data, and where like each row is like one unique, distinct word within each record in our own data example. When we want to train a topic model, what we're basically doing is, say each row is like a record. It's like record 1, record 2, record 3. Everybody see that? Okay, cool. So as opposed to reshaping our data where we'd have, like, if record 1 has 50 words, we have 50 rows for record 1, what we'd end up doing is across all of our records, like the or traffic. And basically, we restructure our data in which each column is going to be a distinct word that exists in all of these records, and it would just go, is it there? Is it not there? Is it there? Is it not there? Et cetera, et cetera. That's how we restructure our data, where we start to do some of those more complicated large language models, where we then start to go, what's the probability that some of these words are tied to certain themes, and to what extent are they going to tie into individual records? But as far as the demo goes, I've thrown a lot at you all, so apologies for that. But we do have roughly about 20 minutes, and so there can be time for a Q&A or some just general questions. And like I said, I can reshare the actual notebook, and we can do some things on the fly. But outside of that, thank you all. I'll post this to everybody. So here's a couple of additional resources. One, here's the actual link to the text mining book. This is the second link is a YouTube tutorial by one of the authors of the text mining book on how you can do some of those more advanced approaches like topic modeling. And other than that, thank you. I really appreciate your time, and my LinkedIn is here at the bottom if folk are interested. I'm always down to answer an email and talk all things data or some of this stuff in general. So. Yep.
Can you speak to how the NRC lexicon data set was categorized? Was it like Mechanical Turk, or was it like a large language model training?
Yeah, that's a great question. So the question was like, how was some of the lexicon, so like in this instance, the NRC, how was that validated? To my knowledge, in the original paper that produced this, it was a combination of, like, I believe, like polling folk like on Twitter, and then some of that stuff also as well with Mechanical Turk. So there are these different, and a lot of these lexicons are different approaches. And so I can post as well to the group like some of the links to the academic papers that have like validated some of these. NRC is particularly interesting because there are different variations. Like I mentioned, my research is in like dehumanization and power, and like there's an entirely separate NRC lexicon that focuses on words that are tied to things like domination, and they've done a similar methodological approach in terms of how they validated and categorized them. And so that speaks into a semi-different area within like psycholinguistics as to how some of these things are put together, but yeah.
But to your knowledge, it was humans, not machines, that were...
Yes. To my knowledge, especially with some of these, with the two that we use, some human validation in relation to that. But that is a good question, and like the thing I will hark on when you are working with these varying sentiment lexicons, doing a quick check as to who put it together, how was it put together is really useful. We used just a couple that were already pre-established in the TidyText package. I've done sentiment analyses in languages like Python, and there are text analysis packages within Python that have entirely different sentiment lexicons, like Vader in particular, that's one that's coming to mind. So there's a component of doing a little bit of a deep dive. How was that lexicon put together? What were the methods that were used? Because there's this deeper aspect of a lexicon may be really useful for general data, but it may not be the best for your type of data. And so especially when you move in a direction of wanting to do a kind of rigorous research analysis on some text data, having that kind of backup knowledge or kind of background knowledge on the methods you've used or how some of these lexicons are put together is going to come into play.
In terms of like the actual like source of the data, like if it comes from like a written text, I imagine like that you might need some additional considerations if like the source is from like a transcript or something, like where when you're talking about sentiment, like the sentiment may change depending on just like the emphasis on certain words or just the overall tone. So I'm just kind of curious, like like what things you might consider if you're depending on the actual source of the text, especially if it's like more like verbal source, if that makes sense.
Yeah, absolutely. That's a great question. What do you do when you have like this different text data sources, stuff that is written, something like transcripts? One of the things we didn't go into here, which you can explore within the context of like even the book or even just on your own. For this entire demo, we were looking at individual word analysis, so like frequency of individual words or like average polarity of like words. You're not limited to that even with this framework. So what we were doing is kind of referred to as kind of a unigram analysis, but we can use things like bigrams in particular where we say, okay, the two words that come back to back are like right next to each other, or even trigrams or quartograms, however, like you can specify, okay, I want my unit of analysis not to just be each individual word, but the co-occurring words that come up next to each other in each. And then that's where you also might see like some themes that come up when you go, what are like the 2 to 3 word phrases that come up in my data. So we're not just limited to that unigram analysis. But you also speak to a really important question where at the end of the day, we can explore, and I would very much call the notebook I shared with you all an exploratory analysis of this text data. But when you start to dive into this a little more deeply, one of the things you're going to want to do is get really familiar with your text data. Some of the students I've trained on some of these methods who kind of work in that mixed methods arena, when we've done quantitative analyses of some of this text data, it's been, okay, but on average, like read through some of the examples so you kind of know what people are saying and what some of these things are, so you can have more of a context. So, but that's a really good point, a really good question.
Where's the link for the notebook?
Oh, yeah, okay. So I can share that on, or I can, let me see, I'll unshare and I'll pull up my GitHub account and I'll like put that.
I have a question building off of you asked before about the diagram and trigram. Like if there's a word that is used in multiple ways and it can be something that can be go both ways, right? If I say you're bad, look at that, you know, that can go both ways. How does that work? It's very conceptual. I don't know about this question.
No, that's very conceptual, but also a really good question. And that's where a combination of editing some of those lexicons may come into play, also creating your own. So especially if you're thinking around like bigram or trigram, for example, like if you're bad or like that's bad, if we know that there's like some like contextual difference, and like our level of analysis might be that like bigram that focus on that. And then we know if bad shows up when that's or your is next to it, we know how to categorize or think about the emotional valence of that differently. So there's a lot of, like I said, those researcher degrees of freedom in the earlier point of the PowerPoint, where these are some useful starting points, some of these lexicons. They're useful starting points to explore some of this data. But when you start to go into the contextualities of your own text data, that might require you to start to edit some of them or even create some of your own. That was probably, like, with some of my work, that's kind of like where I left it at the moment, because I had to go off and do other stuff. But like the questions that, like some of the questions I had of some of my text data was, I'm gonna have to start to create my own lexicons given like what I know about the research and the theory tied to some of this language data. But for purely exploratory reasons, a lot of these lexicons are really useful to kind of just get a general idea as to what's happening in your text corpus.
How would you modify this approach for something more complicated, like analyzing interviews? Is it possible to use any of what we've talked about here to kind of analyze something that?
Yeah, that's a really good question. And so I would say with something like interviews, where you have like much larger data, you can load this up into a data frame if you've put like, you know, bit by bit or sections of an interview. Like if you organize that in like a data set, like in an Excel spreadsheet, you can import that into R, reshape your data in such a way where you're doing that unigram, bigram, trigram analysis. If you have multiple interviews that are really long, we might be stretching the limits a little bit. The data will be much larger, and that's where we'll kind of be going into that topic modeling approach. Like topic modeling is really good for that, where record one isn't just like a 50-word like review, but record one is like an interview that's like 12 pages. And then record two is an interview that's like 13 or 14 pages. When we reshape the data like this, with this kind of larger text corpus, then we can start to do those more advanced models, which in the resources that I'll share back up in a second, you can get to. And the frameworks, the same frameworks that you saw in this notebook, you can kind of run those models as well. Any other questions? Oh, yeah.
Of course, keeping in mind is exploratory in order already keeping in mind what we sort of talked about in terms of sort of creating your own lexicons specific to our own studies. You mentioned that this is a possible approach for sort of open-ended responses, for example, on surveys. Sort of on the topic of bigrams and trigrams, in a situation where I'm thinking especially because I do surveys with people who are often English as a second language learners, when someone uses a particular phrase unconventionally, is that sort of a case where you just sort of make your own lexicon, or?
That would probably definitely be a case right away where you'd make your own, and the key thing that I really want to highlight with all of this is like there's a use to some of these methods when you're quantitatively analyzing, but I don't see them as like a replacement for some qualitative. Like you could do this back and forth. So to give an example from my own work, like I've had studies where I can identify in my data set my participants who have a dehumanizing sentiment towards varying groups and those who don't, and I've asked them why they do have those perspectives and those sentiments. I can cut my data and I can look at emotional valence. I can go, oh, okay, well, in the example of my data, there wasn't, but I use that very much so to inform a subsequent qualitative analysis. So like in something like that, if within the context of your data, if you're like, okay, some of my interviewees like have used like some terms, which I know either colloquially or kind of like in a different context, you can very much categorize that. And it could be like, your data set could look like something like bigram and like context, and you could like create varying categories. So there's a lot of flexibility with how you design your own, and it's just as if you can drum up a data set in R, like creating a new data frame, then, or in Python or what have you, then that would be like a starting approach.
Wait, one question. So since you're at Posit and Julie's at Posit too, I'm curious, like, can you share any thoughts about, recent enhancements or future enhancements to the TypeText package? I know Posit's trying to get more into the Python world, or like, what's the latest and greatest, I guess, in that space?
The latest and greatest, off the top of my head, I don't know. I still work with like the most updated version of the package. Like I said, I have done some broader sentiment analysis stuff in Python where I've incorporated other sentiment lexicons, so like Vader in particular. But some of the new and improved things I haven't worked with as much as of recent. All right. Well, if there are no other questions, like I said, thank you again. Thank you again all for attending. I hope this was useful in some capacity. That is the GitHub link for the repo where I have the data and the notebook kind of there written out. And as well, and then just like my LinkedIn as well, if you have any follow-up questions after the conference or have any other questions. But other than that, thank you all. I really appreciate you all for attending.